All right, I guess we should probably get started. Hi, good morning. How is everybody? Great, 9:30 a.m. Could there be a better time to learn about native apps in HTML5? So thanks all for coming. My name is Joe Marini. I'm a developer advocate at Google. Basically, I lead the developer relations team at Google for Chrome apps, Chrome extensions, the Chrome Web Store, basically what we call the Chrome platform. So this morning's session, we've got, a good solid 3-hour block of time together. There'll be breaks, don't worry. I'm not going to force you guys to sit through 3 hours of me yammering away. But what I'd like to do in this session is, I don't want this to just be a few hours of me just talking away and, you guys just sitting there like this is some sort of university lecture, even though that's what it's called. I'd like to keep this, somewhat interactive. I see that they've got mics on the side of the room to ask questions, but the way that I'd like to do this actually is that as I go through this, we're going to have some time together this morning. You're going to get to know me. I'm going to get to know you. If you have questions, please feel free to ask. If you want me to explain something more in depth, if you want me to stop and go deeper on a subject, that's fine. Just keep a couple things in mind. So number one, I've got these giant bright-ass lights shining in my face, which means I can't see you. So if you want to ask a question, you can put your hand up, and you can just keep right on holding it up. It's not that I don't like you. I probably just don't see you. I may not like you after you ask the question. That's different, right? Yeah, if you have a question and I don't see you right away, just please call out, "Hey, Joe, can you explain that code? Hey, Joe, what's that weird smell?" Whatever question you may have, just go ahead and ask. I'll try to get it answered. The other thing I want to do today is, I had originally envisioned maybe doing something more along the lines of like a code lab. Obviously, we can't do that in this setting because I can't roam around the audience and just answer help you guys out with code or anything. But the way that I've broken this up is there will be a URL that you can go to download some code to follow along with me. And we have a code lab that we did at I/O earlier this year. I'll show the URL for that as well. And later on today, what we'll do is we'll go step through the code lab. And if you want to have the code on your machine, I'll give you a chance to download it. I promise I will do my best to speak slowly. I'm a New Yorker. That doesn't come naturally for me. So please bear with me. If you want me to slow down, somebody just give me a signal, like whatever, I don't know, just get my attention, say, "Joe, you're going too fast." All right, so these are the URLs. I'll leave them up there for a moment if you want to copy them down. The first URL is our GitHub repo for all of the samples that you can use to build Chrome apps. So if you want to take a moment, just go to the GitHub, download the zip file. That way you can follow along with some of the code later on this morning. That's great. The second URL there is going to take you to a Google Doc, which is this guy right here. This is the code lab that we ran earlier this year at Google I/O. And so later on, we'll take a deeper look at the code lab. But if you want to go back, let me put that back up. All right. So in any case, those are the two URLs. You can take photos. That's great. By the way, the slides are all going to be online. But if you want to just copy those down really quick, and I can always go back to them later if you want. So how many people use Chrome today? Everyone. Wow, that's awesome. Man, everyone uses Chrome. That's fantastic. All right, well, you guys have a great day. I know. How many people use the Chrome Web Store to go get stuff, extensions, apps? Great, that's awesome. How many people heard of Chrome packaged apps before today? We lost a few. Okay, that's good though. So, all right, about half of you. So I'm going to spend a little time going into what Chrome packaged apps are. Everybody have that, by the way? Anybody need more time? It's all right, we'll wait. Yeah, all right, I can always go back to that slide. So, yeah, I went over the agenda for today just really quickly. So I'll show some demos, and then we'll talk about why you would want to build a Chrome packaged app. And then from there, we'll just go deeper into what the structure of these things are and things you might run into when you're taking what I'm assuming is probably, many of you probably have existing web apps that you might want to adapt to this format. We'll go into some of that. We'll talk a little bit about mobile because mobile obviously a big subject for app developers, and we'll talk about how we can make our Chrome apps work on mobile devices. I'll go through a little bit of the tools you can use when you develop these things, and then later on, after the break, we'll come back and we'll do some more actual coding. I promise I won't inflict slides on you for 3 hours because I wouldn't want that done to me. So Chrome apps came about relatively recently. At Google I/O back in 2012 was when we first publicly announced that we were working on what would become this new app platform that we came to call Chrome apps. So we announced it, and we had a public preview back in Milestone 25. This was when you could actually build a working Chrome app. It didn't have a lot of the native look and feel that they have today. They didn't like run in the dock, and you couldn't pin them to your start menu. They didn't show up in the menu bar, but they worked, right? You could actually use HTML5 and JavaScript and Chrome APIs to build a working Chrome app. So that was earlier, that was last year. So I/O this year was when we announced our first third-party developers that we were working with to bring real Chrome packaged apps to the platform. We had our sandbox at I/O. We had a half a dozen developers that were in the sandbox showing off the apps that they had built. Some of them you may have heard of, like Uber Conference, for example, Wunderlist, pretty well-known app. So first developers were actually building on this platform. We also talked about our plans to bring these apps to mobile devices. How many people build native mobile apps? Not that many. Some of you, but not that many. How many people would like to be able to build mobile apps that, like, yeah, more hands go up, of course, yeah. So we'll talk a little bit about that later today because I think that's a pretty exciting development. The ability to take HTML5 and build native applications that run not just on the desktop but on mobile devices is, I think, a pretty significant advancement in this area. September of 2013, just a few months ago, was when we shipped the first version, the actual commercial first version of Chrome packaged apps on Windows and on Chrome OS. So if you went to the Chrome Web Store and you had a Windows machine, you had a Chrome OS device, you could actually see these things, download them, install them, run them. They actually work on the Mac, and they work on Linux. But we haven't shipped officially to those channels just yet. That's going to happen pretty soon. It's just that, for those platforms, we need to take a little more time and integrate them more closely into the OS because we weren't really happy with the way that we'd gotten to the point at that moment. So we want to do a better job of getting those apps running more natively on those platforms. So those are in preview right now. If you have the Canary on Mac, or if you're running Chromium on Linux, then you can go to the Chrome Web Store and you'll see these things, but they're not fully officially commercially shipped just yet. So I find often that probably one of the best ways to get people to understand what we're talking about with Chrome packaged apps is to show some demos. So let me do that right now. And I'll just pop out of this. And I'm going to head over to my Canary. You see, I'm on the Mac, right? So I'm kind of flying without a net a little bit here. But if you use Chrome and you've ever gone to the new tab page to launch apps before, you probably have seen something like this. So what I've got in here is traditional like Chrome like hosted apps, but some of these are now packaged apps. So let me show you a couple of demos. The first one I want to show you is Wunderlist. Who's seen Wunderlist before? Right, yeah, it's a great to-do list. I'm sure you guys have seen this. But you notice that this is running pretty much looks like a native app, right? It's got a window frame. It has the Mac native window controls up there. There's no URL bar, right? There's no back and forward button. But this is all HTML5. This was not built using Objective-C and Cocoa. This is actual, right? This is using Chrome as the runtime. And this happens to be a Mac, right? So you can see that up here in the menu bar, there's an actual Wunderlist for Chrome menu. And it's got things that you'd expect the menu to have. And, I can, create to-do items. So I can say, track down people who downvote my session, right? I can do that later. So anyway, looks and feels like a native app. And this is one of the hallmarks of Chrome apps. So let me close this. All right, what else should I show? The next one I want to show really quickly is, you've probably all seen this one before. This is Google Keep. Again, it's a note-taking application. We ship this on Android, Chrome OS, Windows, Mac, but it's built as a native app, right? Again, you can see that it says like all notes saved. These apps work when they're offline. So if you don't have a network connection, they work just fine. They store data locally. They restore from local store. When there's a network connection, they take care of the network. But the UI doesn't go away when there's no connection. So nice UI there. All right, let's go to the next one. Let's see what else. How about, let's show some of the more nicely designed ones. So here's one. If you've ever heard of, who's seen 500 pixels before? Some of you? Okay, 500 pixels is it's a commercial photography discovery site. So professional photographers will use this app to get their work out there and noticed. And again, you can tell it's really nicely designed. So I've got this initial page of images, right? And as I scroll through, like more images are loading in real time. I have a hardwired network connection, unlike you guys, so that's why this is nice and fast. But you can, again, it's really well designed. I can click on an image. I can use my keyboard to scroll through, right? Nice and responsive. Again, this is all HTML5. There's nothing native about this at all. It's all built using web technology. Let's bring up another one. Here's one. Here's The Economist. I'm sure you guys are familiar with The Economist, right? This is a magazine that built a native app, a Chrome app for platforms. One of the nice things about this is you notice, you see down here it says available to read offline. One of the hallmarks of Chrome apps is that they are designed to work offline by default, right? So all of your code, all of your resources are stored locally, and you're basically just using the network to transfer data back and forth. So I can go back here to the initials page. You can see I've got back issues I can download. Again, nice and responsive. I can open up the magazine. I can scroll through, nice and responsive. Works across platforms, so Chrome apps, because it's Chrome, right, works on Mac, Windows, Linux, Chrome OS, and mobile platforms, as I'll get to a little bit later. So up until now, so the apps that you've been seeing up until now they kind of have this native, like you notice they have the native title bar, they have the native window controls, but Chrome apps aren't limited to that, right? You can actually use the power of HTML and CSS to create interfaces that are custom, that they don't necessarily need to look like any one platform. So let me bring up this one. This is a WeatherBug, and it's a weather application. But first you notice it's 45 degrees and cloudy because it's Belgium, so it's nice and cold outside. But you notice that there's no like Mac menu bar up here, right? It's pretty much custom. They've got different Windows controls up here. So if you're not happy with the way that a certain platform displays its controls, or you want to have a more custom look, you can do that. And I'll get into that a little bit later. But the idea is that you're not limited to the way applications look on the platform that they're running on. You can have a much more customized UI. Here's one. This is one that a company called Autodesk did. This is a photo retouching application. And you can see that they've got integration with Google Drive. And I can just open up a photo. This is a photo that I took on the Google rooftop in San Francisco overlooking the bay. And I can do great things in here. I can do things like I can crop my image. Again, this is all HTML5, right? There's nothing native about any of this. This is all being done HTML5, JavaScript, CSS. There's no like Flash involved. There's no Java involved. It's all just web technology. All right, so I think you guys get the idea. So let me just move on. Oh, one other thing I want to show you, just really quick before just to belabor the point. You can actually build pretty advanced applications. If you've ever seen something like Visio before, this is an app called Glyphy. And you can just do diagramming. Again, this is a pretty advanced UI. If I didn't tell you that this was HTML5, right? The idea is you'd never know. Like there's nothing about this that says it's a browser, really, right? So it just gives you an idea of the kinds of things that you can build with Chrome apps. All right. So let's head back to the slides really quick. All right. So then the question becomes, well, why do this? Right? Why would you build a package app? Why would you build a Chrome app? Because the web is great, right? There's nothing wrong with the web. I mean, look, we're Google. We love the web, right? The web is fantastic. There's a lot of great web apps out there. Web apps do lots of things really well, right? They're always up to date because you push code to your server, and then people get the latest version of your app. They run across multiple platforms, right? They're built using one language. You don't have to invest in like lots of different languages to run on different platforms. So there's lots of great things about web apps. Web apps are really useful. Unfortunately, there are times when web apps are just really not so great, right? Working offline is one of those times. We've probably all seen this before, right? You lose the network connection, and suddenly web apps are, well, decidedly less than useful. And even if this isn't, and by the way, this isn't just about like offline being like not online, right? There's lots of different shades of offline. I'll get to that in a little bit. What else? So games, right? We love interactive experiences on the web. Everyone loves, well, not everybody, but like people like playing games, right? You got this nice big keyboard, accurate pointing device. Games on the web are a lot of fun, but there are times when games on the web are just not that awesome, right? It would be nice if you could give people a better gaming experience. You could use things like hardware and read the USB port and attach devices that are not necessarily just, a mouse and whatever else, right? So this is really hard, if not outright impossible, to do in a web app today, right? Web technology does not make things like this very easy. So these, among other things, are problems that Chrome apps are designed to solve. So first, Chrome apps run offline by default, right? They're just built to run offline. So all your code, all your assets, they're all stored locally. They also run across all of the popular platforms because underneath all of this, it is Chrome. So just out of the box, right, you're building with web technology. You're using HTML5 and JavaScript and CSS3. So you get Mac, Windows, Linux, Chrome OS, Android, and iOS just out of the box, right? Just like you normally would building a web app. The nice thing about this, though, is that beyond just access to platforms, you get real access to the underlying hardware. Like you can do things like access Bluetooth and USB and the file system and TCP and UDP sockets and network protocols, and all that stuff is available to you as a Chrome app. You saw before, you can build experiences that are richer, more immersive, much more engaging, apps that look and behave like real apps and integrate with the host OS the way that you would expect an app to behave. So on the Mac, you can pin them to your dock. In fact, well, maybe you saw it before, and I'll show it to you again later, but you can pin them to your dock, and when you Command Tab, they actually show up in the little UI, and if you go to the Spotlight search, they show up in Spotlight search. And on Windows, they go in the Start menu, and they go in the Applications folder, and so they look and feel like real apps to users. And you get the same distribution benefits that you would with the web. So when you build a Chrome app and you put it in the Chrome Web Store, and someone downloads it and installs it, and if you decide to update your app, then every 4 or 5 hours, the Chrome runtime pings the Chrome servers and says, hey, is there a new version of the app? And the store says, yes, here you go. So distribution, same style, not instantaneous necessarily like the web is, but pushing out updates is as simple as just updating your application, putting it on the server, and then users just get the most up-to-date version of your app. In addition to things like distribution, we also provide features like monetization, which I'll get into in a little bit later, but things that just make an overall experience of building an app much easier, much more native for users. So as you go to build these, what you'll find is that there are things that, I'm assuming that many of you have web apps. So when you're building a Chrome app and you're either starting from scratch or you're taking an existing web app and bringing it over to the Chrome apps platform, there are things that you're going to have to be aware of as you do this process, because most web developers aren't used to thinking in terms of certain things like intermittent connectivity and offline access and platform hardware access and so on. So I'll go through the pillars that I showed before. Let's just take a deeper look at each one of these. So let's talk a little bit about offline. So first, what does offline really mean? So the first thing that offline really means is, one, you've got no connection at all, right? I've ripped the Ethernet cable out, I've turned off the Wi-Fi, I forgot to pay the barista for my coffee and the Wi-Fi suddenly goes out, right? Whatever the reason is, right? The network is just not there anymore. I'm on an airplane, I'm in the middle of the ocean, there's just simply no connectivity whatsoever. But beyond just having no connection, right, there's also just bad connections. I'm in some cafe, I'm right on the bubble of where the cell tower is. You're in a crowded conference, like this room, for example, and all of you are wondering why the Wi-Fi is so bad. And So it keeps going in and out for some strange reason, right? So being offline, it's not so much that you're offline with no connection, but many of you, when you're using native apps, probably don't even realize this, right? If you're sitting there typing away, in Sublime Text, or you're using some other native application, if the network is coming and going, you probably don't even realize it, right? Because the application isn't dependent on the UI being delivered by the server in the form of pages. The UI is local to the machine, the data is coming and going, and when the connection's not there, the application just responds to that situation and says, all right, fine, I'll just store the data for later, right? But web apps don't do that. It's very, very hard, if not really difficult, to get a web app to reliably work offline in the browser, right? App cache is kind of useful, but it's not universally implemented, and it's got problems, right? But even if you had the most perfect app cache solution in the world, there'd still be other problems, right? We've got 20 years now of user experience where people just simply don't open their browsers when they're offline because they've been taught that browsers are pretty useless when there's no connection. So it's not just a question of making the technology work, it's also just getting the users to use the application. And so native apps handle this really, really well because they're able to easily recover from connectivity not being there, because it's just by nature of the way that they're built. They don't have to depend on some server for their user experience, which is local to the device. So in Chrome apps, that's how you build your app. All the resources are stored locally, and your app can be launched at any time. And the implications of this are, number one, you've got to figure out what the disconnected experience is going to be, because resources have to be kept locally, except for things like video and audio, right? But all that stuff is local to your machine. So you need to figure out what your offline and online features are going to be. And you'll have to do things like handle things like stale data or synchronization. That stuff kind of becomes your responsibility, although we try to make it a little bit easier. And there are some things that we don't support, just generally speaking. Storing data locally is pretty easy, but in general, one of the things you'll find in patterns of Chrome apps is that synchronous features are not supported. We try to be asynchronous as much as possible. So specifically, local storage isn't there. Why? Because local storage is synchronous, and you don't want your user just sitting there, waiting while your app is uploading or downloading, megabytes of data. So we give you asynchronous versions of things where synchronous APIs would normally block the UI thread. So we try to solve that problem. Some apps obviously don't have a whole lot of value when they're offline, right? When you think about apps like Skype, Skype is a great example of this, right? 95% of the value of Skype is only there when I have a connection, right? But that doesn't mean that the app is just completely worthless when it's offline. I can still do things like manage my call lists and see my call history and look at my contacts and whatever else, right? So even though I can't make a call when I have no connectivity, it doesn't mean the app is worthless. So even the most online of apps usually have some value when they're offline. And it's just a question of figuring out what it is, in your app's case. So to build a Chrome app is actually pretty straightforward. You build it the way you normally would. You simply build your HTML, you build your JavaScript, right? You build your CSS, you take all your assets and you build it the way that you would normally build your app, as if it was a web app. And then you just put some infrastructure around it. So what you do is you define a file called a manifest file, and the manifest file basically explains to the Chrome runtime some things it needs to know about how to run your app, right? What your app's name is, what version it is, what permissions it has, because apps need to ask for permissions to do various things, where the entry points are into the app in order to do certain things like respond to events. So that's what goes in that manifest. It's just a JSON file, straight up JSON, and we'll take a look at examples a little bit later. The other thing that you need to do is provide a JavaScript file that defines the entry points into your app. So when the Chrome runtime launches your app, right, we have to know what function to call because the user started it up, or because it was restarted, or because an alarm went off, or because a push message came in from the server, or various events in the life cycle of your app. So those are basically the two things that you provide in addition to your HTML code. And then all of that gets wrapped up. So that all gets wrapped up in a package. And this is what gets stored locally on the user's machine. Right, so all this comes down. It's a zip file. It's packaged up in what's called a CRX. That's our proprietary format. That's what goes in the store. That's what comes down to the user's machine. It gets installed, and it looks and runs like a regular app. Any questions on this so far? Pretty straightforward? Yeah? All right, remember I can't see you very well. All right. So what this means is you have to plan for having a great offline experience. So that includes factoring your app to store resources locally. You have to have separate JS and HTML files. You can't do things like have inline JavaScript in your files. I'll get into that later, why you can't do that. But things have to be separated and stored locally. You have to remember that what you're transferring back and forth to the server should be data, not UI. Don't try to do things like generate HTML on the server and transfer it to the app. That very quickly breaks down. For some situations, it's fine. Right? For some situations, if you're doing templating or whatever, or if that feature of your app is only available when it's online, that might be okay. And we have a way for you to embed a rich web view, which is Chrome, inside your Chrome app, which I'll get to later. But for the most part, what you want to make sure you're transferring is data. You don't want to be transferring HTML back and forth. That just breaks very, very quickly. So as I mentioned earlier, figure out what it is you want to provide offline, what features do you want to make available that you want your users to be able to use. Because this is Chrome, because the runtime underneath all of this is the Chrome runtime, you have access to all the standard HTML5 and JavaScript stuff, right? So the navigator.online property is there. The events that are going on and offline are there, so you can respond to them. Just remember that they're not very granular, right? The Navigator Online property doesn't say things like, hey, you've got a slow connection. It basically just says you're either, the cable's connected or not, or the Wi-Fi is on or not. It's not, it's not perfect, but it's there for you to use. We do give you multiple ways of storing data. You can use our API, which is asynchronous, and it's analogous to the local storage. If you want to use IndexedDB, that's fine too. We give you full access to the file system. The HTML5 file system, it's an actual HTML standard. It is a W3C standard for accessing the file system, and we give you APIs for that. So however you want to store data offline, there's many, many ways to do it. Here's an example. So let's imagine I had a form with some data in it, and I wanted to store it on my machine. Where I would normally use local storage, what I'm doing instead here is using the Chrome Storage API to set a dictionary of data. And because it's asynchronous, right, I just have a callback function that says, hey, your data got saved. And if you care, that's great. If you don't care, that's fine. You store the data, off you go. All right, so in addition to being offline by default, we designed Chrome apps to be cross-platform by default as well. And by cross-platform, when you think a long time ago about when you delivered native apps, the way the world was back, some time ago, all you had to care about really was Windows, right? You built a native app, you delivered it on Windows, and that was pretty much everybody in the world. If you really cared about the 5 to 10% of people who didn't use Windows, you built a Mac app, and that was pretty much everybody, right? Today, the world is obviously a lot different, right? Today, you've got, Windows, but you've actually got multiple versions of Windows, right? And of course, we still have the Mac, but there's lots of versions of the Mac out there today. And that, there's also mobile platforms, and even Linux is more popular today. I think Ubuntu has 20, 25 million users now. Chrome OS is becoming a lot more popular. That's based on a version of Linux. So delivering an application across platform has become a lot harder. We've seen this really great resurgence in lots of different native OSs that provide really great, rich platforms, which is great. I mean, it's great that people have the ability to choose these great devices and hardware platforms that they want to use for their apps. But as developers, that makes life more complicated, right? And the problem with this picture is that if you really wanted to deliver great native apps across multiple experiences, there's lots of different costs that are involved in this, right? So, just in this picture alone, if you wanted to deliver native experiences on Mac and Windows and iOS and Android and so on, well, I mean, so for Windows, you're talking about C# and .NET, right? Mac is going to be Objective-C and Cocoa. So is iOS. Android's going to be Java, right? Linux is probably going to be Java, maybe C++. So, there's a lot of different skill sets that you'd have to invest in if you wanted to deliver really rich experiences across all of these. And it's not just the language cost. There's all kinds of hidden costs that developers tend to forget about when they're building apps, right? Things like, installers and auto updaters, right? The internal guts of things that keep things up to date. A long time ago, back when I worked at Macromedia, I was I got the unfortunate distinction of being the installer guy for Dreamweaver. And let me tell you something, if you ever get tagged as being the installer guy, man, I feel for you, because that is not a fun position to be in, because you become the installer guy. And then, yep, you're the installer guy, and then everybody comes to talk to you about the installer, and you will never, ever, ever shake that distinction. You will just be the installer guy, and that's the end of that. But that's the kind of stuff you want to avoid, right? You want to avoid having to do things like that to build native experiences. So that's what we're trying to get out of Chrome apps. So what we've taken the Chrome browser, and we've separated out the runtime from the browser UI. So now you target Chrome just the same way that you would target .NET or Java or any other runtime. It's just a runtime now. And so, Chrome is on the user's machine, and your application gets installed. It just runs like any other app. So that's what we're trying to get to. So the driving philosophy behind Chrome apps is that Chrome apps run wherever Chrome itself runs, right? So that's the major desktop OSs today. That's iOS and Android. So that's what we're trying to get to, is wherever the Chrome runtime runs, and wherever it runs in the future, right? Chromecast, for example, other runtimes. The idea is that you'll be able to build these apps, and they'll run where Chrome is. And because you're building on top of Chrome, and because it's web technology, you get all the same great developer tools that you get when you're building web apps. So how many people use the Chrome developer tools to develop their apps? Yeah, see, almost everybody. If you're not, you're probably using Firebug, right? But at the same, you get to use the same tools. It's the same tool set, the same debugger, the same pretty much everything that you're used to in building your web apps. So it's a really nice developer flow, and I'll show that a little bit later when we get into the code section. All right. So I spent some time talking about like cloud, offline and cross-platform, but we also live in a cloud-connected world, right? One of the great things about applications on the web and the internet is that they're connected. Devices are connected to the cloud 24/7 now. So we wanted to make sure that when you're developing Chrome apps, they're also cloud-enabled by default. We wanted to make it really easy for you to build applications that can connect. So obviously, users expect this, right? It's become just this de facto thing where if your app isn't connected to the web or the internet, that's a problem. And so users look at this and they say, well, it's just something they expect your app to be able to do. So your app might be used across multiple OSs and multiple form factors, and even different machines on the same OS. People might have different machines either at home or at work, and they're using the app at the same time on different machines. So we wanted to cover those scenarios and make sure that you could build apps that are connected in a really easy way. Now, this obviously gives rise to the possibility of data sync conflicts and so on, but you get to specify how these things get resolved. And so we give you a bunch of Chrome runtime features that address these scenarios. So first, earlier I showed the Chrome storage local API, right? Well, there's a sync version of the Chrome storage API. If you guys have used Chrome, right, and you've used it on different machines, you've probably noticed that things like your bookmarks sync across multiple devices and multiple instances of Chrome, right? Well, we just give that to you. We give you that infrastructure as part of the Chrome runtime. With a couple of lines of JavaScript, you can just write an application that syncs things like application settings and pieces of data across multiple instances of your app. You call our API, and you're done. In addition to the HTML5 file system locally on your machine, we give you access to the sync file system. And this is a cloud-backed file service that, out of the box, it uses Google Drive. So you can do things like store large data files, and using the Drive backend, it will sync those data files across multiple instances of your app. Now, it uses Drive by default, but it's open. So if, I don't know, like Dropbox or somebody wanted to build an integration that used the sync architecture, they could do it. But just out of the box, you get Drive-backed file synchronization. There's also a cloud push messaging API. So one of the great things about Chrome apps is that even when your app is not running on the user's local machine, right, the Google runtime, the Chrome runtime is running for you. It's always there. So even if your app isn't running, your servers can send a cloud-based message through the Google servers, which will then find the user's machine out there on the network and send a cloud message to your app. The Chrome runtime will then wake your app up, and then you can do whatever you want, right? It's a really great way of maintaining engagement with your users. And again, it's an example of something that web apps can't do today, right? Web apps can't just simply wake up the browser and go to some URL and start doing things, but Chrome apps can do that. So we provide that API, we provide that backend infrastructure to you, which is part of the Chrome runtime. How many people really, really love writing OAuth code? Yeah, I don't either. And so we made identity management and authentication easy by providing an identity-based API. So there's two versions of this. It's one API, but there's basically one function call that you make in order to authenticate the user against whatever their Google service may be, right? So if I'm a G+ user or Gmail or whatever, and the person is signed in using their app, then you make a function call, and it gets you the Google credentials, and then you can go off and do whatever you want with that token. But if you're using authentication on a third-party service, like, I don't know, like Twitter or whatever else, right? There's another auth flow that you make in that case, and it handles the web-based authentication for the app, and then you get the token, and then you go off and do whatever you want. So let's take a look at a couple of examples of cloud APIs. So using the synchronized file system, so basically we have a function here called set conflict resolution policy. So if you want to sync data between your apps and you're using the drive-backed version, you can specify things like you want the last write to be the winner, or you can say, nope, I want it to be manual. I'll just handle sync conflicts myself. It's up to you. You get to choose. And then you use it the way that you would normally use any one of the HTML5 file system APIs. You basically call request file system, which is part of the W3C spec, right? That gives you a file system object. And then you just simply go off and start writing files. And they'll be synced using Drive on the back end. It's really simple, really straightforward. For identity, here's an example. The first one here, get auth token, that's the Google services version. So you can specify whether or not you want this to be interactive. You can make it optional if you want to. And typically the user is signed into Chrome when they're doing this. So you can simply get their credentials. The little dialog will pop up and say, hey, this app wants to know who you are. And you say yes or no. And most of the time, however, there'll be no UI involved because the user will just be signed in. The launch web auth flow version is the one for third-party services. And the way that OAuth typically works, right, is that you have to give it this like redirect URL, and then you call the third service, and then Twitter calls back to you. They redirect to some URL. You've got to get the token out. Well, Chrome apps are not in the browser, right? So there is no like URL to redirect to. So what we do is we give you this callback function right here, and this is where the third-party service would call back into. So we handle that for you, and then you just simply get the token out of that function callback, and then you're off and running. So it really greatly simplifies the OAuth process. You don't have to deal with a lot of the stuff that OAuth has to do. All right, let's talk a little bit about UI. So I showed you this earlier, right? Chrome apps, they live outside the browser, and they can have richer UIs and richer experiences. So this has some implications, right? So your app is responsible for things that it was not responsible for in the past, and I'll talk a little bit about that. And users, generally speaking, have different expectations of apps versus websites, right? They expect apps to be more responsive. They're kind of understanding when a website has to go off and fetch data from the web and so on. Native apps, they don't have, users expect native apps to be a little more responsive than that. So to build a great user experience, we give you a full window API to manage your app's windows. Because on the web, right, when you're a web app, the browser just says, well, here's how big your window is, right? And your web app is like, okay, I guess that's how big my window is. And so you're not responsible for things like remembering where the window was or how big it was, right? But apps are different, right? I mean, imagine how annoyed you would be if you get Sublime Text just as big as you want it, positioned right where you want it on the third monitor, and then you quit the app, and then you bring it back up again, and it's this big, right? That would drive you nuts, right? Well, this is what users expect of native apps. And so you have to, when you're a native app on the platform, you've got to do things like remember how big your window was and remember where it was. So we give you a window API where you can do things like see how big the screen is, how many screens there are, and you can use that to figure out where you want to put your initial window positioning. You can go full screen if you want to. So if you're building like a game and you want to take over the whole screen, we give you a full screen API. So your app starts up, it goes full screen, right? Again, these are things that are hard to do on the web. As you saw earlier, you can control whether the default OS title bar is shown, whether or not they get the default window controls. It's all up to you. There's a CSS property that you simply put on whatever region you want to be the title bar or whatever you want to be able to drag the window around. It's called WebKit App Region Drag. You put that on whatever objects, divs, whatever you want to be the drag region, and you're a native window at that point. We give you a full context menus API. So users have this really annoying habit, right? They right-click and they expect something to happen. And doing that on the web is a pain, so we give you a native context menus API to make that work. The cool thing about the context menus is that they work outside your app. So you can specify context menus that go on your launcher icon. So if your app is in the launcher, whatever platform it's on, right? The user clicks on it, you can specify context menu content that goes in that icon, which is a way of giving the user richer engagement in your app. There's a full alarms API, so if you want to set alarms to happen at a later date, again, this is stuff that you can't really do on the web. And we give you a media galleries API to get access to things like photos and movies. All of this, by the way, is hidden behind permissions. So your app has to specify that it wants to be able to do these kinds of things before it can do them, obviously, but there are APIs to do all this stuff. There's a system info API to get things like what the CPU is, how many displays there are, how much storage space there is. So you can provide really robust, fully featured apps that do things like don't try to write to the disk when it's about to be full, or detect the fact that there's more than one display, and you can intelligently place like your design surface here and your palettes over here. And so it's all about building a nice, rich native experience with these APIs. So just to be clear, the APIs I'm talking about here are not in the browser, right? They're only in the Chrome runtime for apps. Some of these are available to extensions, but not all of them. And the reason we're doing that, we're not making them available in the browser, obviously, because we don't want to we don't want to fork the web, right? So we want to make sure that these APIs are only limited to extensions and apps. Now, having said that, however, our philosophy with Chrome apps is use HTML5 wherever possible. Use the standard JavaScript APIs, the standard DOM, wherever we can. And if the spec doesn't provide for a certain feature, that's when we fill it in with a Chrome API. But even when we do that, we do it with an eye towards eventual, hopefully, standardization, right? A good example of this is the manifest file I talked about earlier, where you specify how your app looks and what its features are. We're not the only ones doing this, right? So Microsoft has Win.js apps for Windows 8. Mozilla is working on, Firefox OS, where you build native apps that run on their mobile phones using Firefox OS. There's no reason why our manifest file needs to be any different from theirs, right? It's just a way of specifying an app. So we've already started talking to those guys about how we can standardize some of this stuff. And hopefully, a lot of the APIs that we're providing will eventually find ways into the standards as well. But for the moment, our approach is, use the standards wherever we can, and then fill in APIs where we have to. But then, again, even when we're doing that, try to use standards. So, for example, in the sync file system, we just use regular file system objects that the HTML5 spec gives you, right? Because we don't need anything special there. We just simply need a way to give you a sync version of it. So it's the same API as using any other file system. That's just a good example, right? So that's our philosophy with these APIs. All right, that's actually a pretty good segue into accessing the platform. So this is something that web apps just can't do, right? Web apps can't just simply go off and get the Bluetooth radio. They can't just simply go off and get the USB port. They can't just simply go off and get the network and say, hey, what devices are out there? But when you're building real apps, you have to be able to do this, right? You've got to be able to write files. You've got to be able to, access devices sometimes. You've got to be able to communicate with the outside world. And so we gave Chrome apps APIs to do this. Now, of course, once you start opening up the user system to things like Bluetooth communication and USB ports and so on. Privacy and security become really, really, really paramount here. They're very important. So these are things you have to think about. And you really want to be clear to the user about when you're using platform resources. In some case, you don't have a choice, right? In some case, the system takes care of this for you. Like you open up the camera, and that little light goes on, and you have no control over that, right? So the user's pretty clear, hey, my camera's on. But it's not always clear when you're like writing files or using the network. So it's good to be clear to the user that you're consuming resources. And of course, you got to be a good citizen. You got to release these things when you're done. Not all these. Don't just simply let your app exit, with some hanging connection open or whatever. You've got to, these are things you need to think about when you're an app developer. So I talked a little bit about accessing the file system. So this is a pretty good example. In some cases, so in regular web apps, right, you have the little choose file button, and you have a file picker that comes up, and the browser will give you a file handle when the user chooses a file. The problem is that has to be user initiated, right? The user has to be involved, and this is one of the things that stands in the way of building an app like on the web today. How would you build something like Sublime Text, right, or iTunes, or it's very hard to do. I mean, you could do a lot of it. You could actually, because Google Play Music kind of does this, right? It does play music in the cloud. The problem though is that you don't have things like arbitrary access to a user's directories, right? There's no way to just enumerate the contents of a directory. The user has to be involved in choosing every single file, and that's not a very good user experience. So the user has to initiate a lot of this stuff. But what you'd like to be able to do is simply get access to a directory, right? Get access to the media galleries and upload content and download content. And so we give you those kinds of capabilities in Chrome apps. In this particular example, what you're doing is you're basically saying, I have an app that accepts these file formats, and then I have a Chrome API that just lets the user invoke the choose file dialog whenever they want. Now, in this case, I'm choosing a file, but I could choose a directory entry. And what's neat is that if you look on the line here, you see I'm using the local storage API to retain access to the file entry after I get it, right? This is something you can't do on the web. So what my app is doing is saying, hey, I want to have access to this file and without having to bug you about it ever again, right? And again, there's a permission that goes in front of this, but now once I've done this, my app can just read and write this file. So if it's a preferences file, for example, I don't have to bug the user every time I want to access this file. You can do the same thing with directories. So if your app, you're building some photo batch processing app, right? And you don't want to have the user choose images every single time, you can just simply ask them for access to a directory. Every time they put images in there, your app can just access them and enumerate them, and you can retain access to it. And then we give you additional methods like being able to get metadata about files, like when they were modified and how big they are, what their paths are, that kind of stuff, right? So you can build really rich integrations with the underlying OS using these kind of APIs. All right, so now we get into one of my favorite subjects, and by favorite, I mean one of my least favorite, which is application security. So does anybody know, who knows what content security policy is? Oh, I feel so bad for you guys. Yeah, if you don't know what it is, count yourselves lucky. You will need to know what it is. Hopefully you won't need to interact too deeply with it. But content security policy is a way of specifying what an application can do with content and where it comes from. So for example, I put a link here to CSP in the document. Actually, let's just go ahead and take a look at it. One of my colleagues wrote an article about what CSP is. If you go to HTML5 Rocks, you can read about it. It's basically a way of saying, here's a whitelist from where things like scripts can come from, and here's where other content can come from, and here's what my application is allowed to do with things like new function and so on. Let me go back to the slides. But the idea is, we're doing it first screen. The idea is that because these applications are running locally on the machine, security is really paramount. If you thought that cross-site scripting attacks on the web were bad, they would be really, really bad if a local application were to be compromised. And so Chrome apps put a pretty strict security sandbox policy in place on the apps. So for example, each app is sandboxed into its, by default, its own local, say, file system sandbox, right? So by default, Chrome apps can't just simply go write data to your system. Even if you do grant access to the outside world, Chrome apps can't do things like go right to your system folder. They can't, there's lots of sensitive places where they're not allowed to go. And CSP handles a lot of this stuff. So in the world of Chrome apps, that has some implications. So first, you can't do things like, by default, you can't use things like eval, right? Because eval is a notorious source of problems whenever you're trying to evaluate JavaScript code in line. You can't do things like use new function inside of a Chrome app. Again, lots of security issues here. All of your JavaScript code has to be in separate .js files. You can't have a head with a script tag and a whole bunch of JavaScript code in there. Because we have no idea how it got there, right? If somebody's able to get control of that page somehow and they put script code in there, that script code has access to whatever's in that page, and we can't have that. So when you declare a JavaScript file with JS code in it, right, and it's in your manifest, we know that it's there, we know it came from you, and it's much more secure. You can't, along the same lines, you can't do things like inline event handlers, right? So you can't have body like onload equals whatever, right? You have to do the real event way of like adding an event listener and so on. If you use iframes, and you can use iframes in Chrome apps, but iframes are sandboxed into their own local origin. And what that means is, they're not considered to be from the same place as the Chrome app is. And that's a security mechanism, number one. But there's a very hard boundary between your page and the iframe. Now, you could do things like post message, right? You can post a message from the iframe out to your parent window, from the parent window down into the iframe. But there's no way for the content of the iframe to poke through that boundary and start calling Chrome APIs inside the application. The content of that iframe can only do standard web stuff. And you need to, I think I mentioned this a little bit earlier, but you need to declare where your content comes from if it's not local. So for example, in your manifest file, you have to ask for permission to access certain URLs. So if you want to do things like XHR to go get data from a remote resource and bring it down locally, you have to have permission to access that URL. You can't do things like have static images just out on the web somewhere. So if we go back to the example earlier of the Economist app, you saw those pictures inside the app. One of the things you can't do is you can't have an image tag with source equals like path to some random image on web, right? That image has to be stored locally in the application's local resource package, right? So obviously that's a challenge because for images that are changing, especially for like something like a news magazine, right? What they're doing is they're going out, they're using XHR to bring those images down locally and then refer to them using object URLs. And because that's a pretty common scenario, we actually give you an open source library on our GitHub repo that does this for you. There's a remote asset loader where all you have to do is just say, I want to go get assets from this URL. It'll bring it down locally, store it, and give you an object URL that you can use to refer it with. It's pretty straightforward. So just to give you a quick example, here's the old way of doing it. You've got a script tag with script in it, inline event handler. You can't do that. Right. The right way to do it is the bottom. We have window.event, add event listener, right? Have your script in a separate JS file. So just keep that in mind. But then, of course, I always get the question, but wait a minute, I really want to do that stuff. I really want to use eval. I really want to use, and I have to because I've got some templating library that uses new function and evaluates code and so on. So what do I do? Well, you can actually do that stuff if you really want to. We give you ways of including code that would ordinarily be insecure in a safe sandbox way. So the first thing you can do is you can embed web content in your apps. We give you a special tag called a WebView tag, which is a way of embedding Chrome inside your Chrome app. And it gets a little Inception-like at that point, but you can do it. The difference is, it's basically a rich web view surface. It's not Chrome the browser. Like extensions don't come in. It's just the rendering engine. But you can use that to embed rich web content that's interactive inside your app. In fact, one of our GitHub samples actually shows how to do this. It shows how to make a browser using the web view control. And same rules. You can post message back and forth, but you can execute script in the context of the web view, but the web view can't get into your app and start doing things. So for accessing remote resources, I think I just said this actually, you basically use XML HTTP request, bring the content down locally, access it using either a file or a data URL or an object URL. Again, we have a library for this, so you can just do this. Typically what happens is you're using something like a templating library, right? You're using, I don't know, pick your favorite templating library, and it's doing something like, eval or new function or whatever. So a couple of things you can do here. First, you can either use a library that pre-compiles its templates, right, which gives you a ready-made function for doing templating. So Handlebars, for example, does this. There's others, but you can pre-compile your templates. Another thing that you can do is use what's called a sandboxed page. So Chrome apps give you a way of specifying a page that's inside your app, and it's part of your app, but it's inside this little sandbox that can't do things inside the Chrome app API namespace. But suddenly you can do things like eval and new function, and you can send messages to and from the sandbox page. So what you would do here is you would include a sandbox page, include the templating library in that sandbox page. It goes off and does whatever it does using eval, new function, whatever, and then you've got some code in that page that takes the results and posts it back to the app. That way the app can get access to whatever functions it needs to, and the sandbox page can go off and do unsafe things, but it's in its own little universe where it can't get access to your app. All right, let's talk a little bit about mobile Chrome apps. So how many people know what PhoneGap is? Many of you? Okay. So we started working on a framework for mobile Chrome apps based on the Apache Cordova framework. How many people know what Cordova is? If you know what, okay, yeah. So Cordova is basically the open source version of PhoneGap. When Adobe bought PhoneGap, they open sourced a lot of the code and called it Cordova. So the same way that the Chromium project is to Chrome, right, where Chromium is the open source version of Chrome, that's what Cordova is to PhoneGap, right? It's just the open source version of the code. So what we're doing is we're porting a lot of the key Chrome apps APIs over to mobile on iOS and Android using the Cordova framework. So what happens is the mobile Chrome apps execute in the context of whatever the host web view is on the other OS, right? So on iOS, it's their UI web view control. On Android, it's the web view on Android. And initially, we're going to do those two OSs, and then we'll look at others as the need arises. So basically, what you do is you build your app once. You use Cordova to host your web content, and then the Cordova framework has a whole lot of APIs already for doing things like vibrating the device or whatever. And then we're bringing a lot of the APIs that we have in the Chrome platform, things like identity and sync and all that stuff. We're bringing that as a set of plugins. The developer workflow is actually pretty straightforward. You basically install the mobile tool set. So you install the Android developer tools, you install Xcode, whatever, right? You can either start from scratch, or you can import your existing Chrome app, right? All the HTML and JavaScript assets. And then you just do the same web developer workflow you normally would do, right? You iterate over the code. You can debug using the Chrome dev tools. And so you basically get your app in good shape, and then you distribute your app. Now, because these are native apps, right? In this case, they're actual native apps in the platform. They go in whatever the native web store solution is for that platform. So on Android, it's Play. On iOS, it's the Apple App Store. So these don't go in the Chrome Web Store. Okay, these are regular distributed native apps. So we're initially going to support a core set of Chrome apps APIs. So these are the ones that we're going to support to begin with. Some of these will work on iOS to begin with, some won't. So a good example is payments. There's no way that Apple is going to let us handle payments on their system. They're just not going to do it, right? So we're not going to have that API to begin with on iOS. But things like TCP and UDP sockets, things like identity, the synchronized file system. Actually, I believe notifications are about to be there on Apple as well. I think when I made this slide, they weren't there, but they're about to be there. And the alarms, all of that stuff is going to be brought over to the iOS and Android system. At some point, we'll get things like storage on there and other APIs as well. But just to give you guys an idea of the kinds of things that you can do, let me just go back to my Canary for a second. So this is an app that we built as a sample. This is an internet relay chat client, Circ, and it's available, in the Chrome Web Store. And you can see that basically, it's connected to the IRC. I'm in some chat room, I guess. I've set my nickname to be whatever. Yeah, I'm on irc.freenode.net. So this is a socket-based application that's connecting to IRC from within Chrome apps. So I actually have my phone right here. So let me show you this really quick. I'm working live without a net, so hopefully this works. Let me go over to the, let's see, Cordova IRC chat client right there. Right, I'm going to freak out the cameraman for a second. All right, so can you focus on that? Focus, grasshopper. There it is. So same app, right? Same code base, same everything running on a phone and on desktop. It's all HTML, all JavaScript, and it's the same app. So using Cordova, right, you can get a TCP socket-based app running on your phone as well as your desktop. So that's the kind of stuff that we are looking to let you do. All right, let me just do a quick time check. Okay, so I've been yammering for about an hour. So we have a little bit of time left. I think now is a pretty good time to just take a quick break. What I'm going to do, this is a quick summary of the stuff that we talked about. So just to quickly wrap up the first hour, we talked about building apps that are offline by default, right? Things that are cloud-enabled. I showed you guys things like immersive user experience, how to access the platform. These are all things you can do in Chrome apps. And then we talked a little bit about security and a little bit about mobile. I don't have that on the slide, but we talked a little bit about mobile. So what I'd like to do is let's just take a quick 15-minute break. And when we come back, I'm actually going to start going into the code for how this stuff was built. And you can see how the apps actually work. I'll put the URLs back up on the screen, so if you missed it the first time, you can download the zip file, and you can have the code ready to follow along with me if you want to. Before we break, though, are there any questions about stuff that I've shown before we get into the code in the next part of the session? Any questions? Don't be shy. Come on. All right. Well, if you think, yeah, I see it. Yeah. I'm sorry, what? Can you access the... Can you have a URL that accesses a Chrome app? Yeah, so actually this is a new feature that we're about to introduce in the next milestone of Chrome. You'll be able to specify that your Chrome app is a URL handler, right? So you'll be able to say, so for example, somebody gets an email message with a URL in it, right? If they click on that URL, your app will be able to say, oh, I take care of that. Now, for security reasons, you have to own that URL, right? Your app can't just simply say oh yes, I handle Gmail URLs. So you have to prove ownership of the URL via the Google Webmaster Tools or whatever, right? But you will be able to have an app that actually fires. So for example, if your app is a photo thing and you've got a URL that displays photos, you'll actually be able to say, hey, my app does that, and then it'll fire up the app and run. Other questions? Remember, I can't see you. Yeah. So the question is there a way to provision Chrome apps for things like an enterprise or an internet thing? Yeah, so there is. So Chrome apps are hosted in the Chrome Web Store, but they don't have to be listed publicly. You can actually just give people the URL to a Chrome app, and they can either go there, right, to the Chrome Web Store and get the app if they've got the URL, and nobody in the public world can see it. That's one way to do it. Another way to do it is if you're a Google Apps customer, you can get your own little private version of the Chrome Web Store to provision apps to people in your domain. So there's a couple of ways that you can do this, right? You can also specify Google Groups. So if you have a group of people that you want to have access to the URL, then anybody who has the URL but isn't part of that group can't access the app. So there's a few ways that you can provision apps internally in your enterprise or internet setting. Other questions? Yeah. Is it possible to monitor file changes in a specific directory? We don't have an API for that just yet. Right now, you have to pull. Not every platform provides that, actually. So there are some platforms where there are events that happen if a file changes. We don't have that yet. It's something that's been requested, and we're looking at being able to do it, but not exactly just yet. So, yeah. Okay, so the question is, for the identity API, does it work with two-factor authentication? I think that's something that you just specify on the server side for your app. I've seen it happen. I think you have to specify that on the authentication side of your app on the server. It's not something that the client has to worry about. But I believe it does work with the two-factor authentication. Yeah. Yeah. So the question is, how would this compare with Node WebKit? So Node.js is intended to be, well, I mean, it basically works on it works on the server side, obviously, right? But you can run a local version of Node.js. I think what we're doing here is, it's very similar in some ways. I think that Chrome packaged apps are intended more to be not just APIs, but way of packaging apps for distribution and easy consumption on the front end. I don't know much about if there's any way for Node.js apps to have like a nice UI on them or anything like that. They seem to be command. Okay, I haven't seen it actually, but it sounds like it might be similar. But one of the things that we're doing is, we're providing a standard API on top of a lot of the not just Chrome service, like not just Google services, but OS services. So I don't really know much about the WebKit portion of Node.js, but I don't know. Sounds like it might be kind of in the same vein of things. So, yeah. So the question is, can I use my own native code as part of the package? You mean C++ code? Or Java? So we have something called native client, which allows you to embed native code inside your app, but it's basically C and C++. It's not Java. Now, one of the things that you can do in a Chrome app is you can message from a Chrome app to a native running app on the system, right? So if you have an existing native app that's built in, say, Java or whatever, right, you can pass messages back and forth from a Chrome app to a native service. So that might be a potential solution. Yeah. Yeah.
Follow-up question to that. Can I start a Chrome app more or less like, can I have the user start a Java application and have the Java application start a Chrome application, and then I don't really want to see anything other than...
Yeah, so the question is, you want to have the Java service like have some command line argument that starts up an application, basically, right? Yeah. So I believe there is a way to do that. I don't know if it's officially documented just yet because we're looking at ways to make that seamless on different platforms. Follow up with me on that after the session because that might be, I don't know if it's there yet, but it's something we looked at. Yeah. So the question is, can you build an app that still works in all the browsers but uses some of the Chrome app APIs? So one of the things that you can do is, so we give you this web view control, right? So you can build an app that has some server-based stuff that's in the cloud and is delivered via the browser, right? And you can host that in the Chrome packaged app via the web view control, right? And now the way that you would take advantage of the Chrome APIs is that web view would then message out to the parent app and say, I want to do Chrome stuff, right? And you basically your web app inside the web view would just detect the fact that it's inside the web view, right? And it knows how to message out to the parent app. And then you would feature detect that, right? And then if that wasn't there, then you're running in some other browser that isn't a Chrome host and doesn't have the Chrome APIs. So that was a pretty long-winded way of saying yes, right? But there's some machinations you have to go through in order to get that. Yeah, so the web view basically is, for all intents and purposes, it is Chrome. And I'll show after the break, when we come back, I'll show an example, because people are asking about this. I'll show an example of this after the break. But yeah, you can host Chrome inside your Chrome app. It's actually kind of cool. Yeah. I'm sorry, is there what? Yeah, the question is there a security list? Basically, so inside the manifest file, you simply say, I want permission to these URLs here. Now, inside the web, now in the web view, what you can do is, so since you have full control over the web view, there's no URL bar, right? It's just a display surface. So your application can control whatever URLs do and don't go into that web view. If your application opens a socket, you can go anywhere you want. Sure, yeah. If you want to build, so we actually have a sample. I know this is going to sound crazy, but we actually have a Chrome app sample that acts as a web server. So it opens up a TCP socket, listens, right, and it can handle web requests and do whatever. So yeah, you've got a lot of power at your disposal, behind permissions, obviously, but yeah. Yeah. So the question is about security and installing unknown Chrome apps. So the same way that you install an app on a mobile device like iOS or Android, right? There's a list of permissions that the app is allowed to access. So at install time, right, you get a little message that says, hey, here's what this app wants to do, right? It wants to read and write files. It wants to go to these URLs. It wants access to all your, it wants access to your media content and your media folders. So you can decide at install time whether you want to grant this app access to these permissions or not, right? So just like any other OS, if you don't want an app to do that stuff, you just don't install it, right? But yeah, there's no way for an app to just start going and doing things that you just don't know about. It has to have permissions to do that. Yeah. Well, the app can do things in the background, but it can't do things it doesn't have permission to do. Yeah. All right, so let's stop here, take a 15-minute break, and then when we come back, we'll do some. I'll show you guys some code, some real actual code. I know, right? So I'll see you guys in 15 minutes. If I didn't get to your question, just feel free to come on down. Yeah.